So let's first talk a little bit about the hypergeometric probability distribution and recap what we talked about in the previous video. So we said with a hypergeometric distribution, it's kind of similar to a binomial distribution in that the population is made up of successes and failures, okay? But where it differs is in that the population is a finite thing, okay? We have a finite number of n objects in our population. Okay, and we know exactly what those n objects are. And we know that this population is made up of two different categories, successes and failures. Okay, and we know exactly how many successes there are. There are little r successes out of that n. Therefore, there must be capital N minus little r failures. Okay, and we know exactly what they are. Okay, we know exactly how that population is made up. So if we observe, if we take out one of these n, one of the values of n, one of the observations at random, and observe it, and if it's a success, then that changes the probability of picking out another success, right? This thing is finite. If we view one success, that means we have one fewer success to view if we're going to pick another one out, okay? So here, the probabilities are dependent upon each other. In the binomial distribution, they weren't dependent on each other. That probability of a success was the same every time, right? Because we were assuming the population was large enough, we were drawing from this huge population that it didn't matter whether we viewed a success or a failure. It wasn't going to change the probability. Here, that's not the case, okay? This is without replacement, okay? We're not replacing this. Once we view a success, we're not replacing it back into the population and not changing the probability of another success, okay? Here, whenever we view a success, that alters the probability of another success. Okay, got that out of the way. So we've got these two categories in our population of n, and we're going to pick a sample of size little n. Okay? And we want to know, out of that little sample, little n, what's the probability that we see some number of successes? Okay? So we're going to name a random variable y. That's the number of successes that we view in that sample of n, okay? And so we might want to know what's the probability of 2 successes out of 5 or something like that, where we know exactly how many number of successes there are in the population. So what's the probability of y taking on some value, little y? Okay, what's the probability of this particular realization of this random variable? Well, first, we're going to count the number of ways that we can get little y successes out of the population, okay? How many ways are there for us to pick out little y successes out of this population? Well, there are r successes. So there are r choose y number of ways that we can pick out little y successes from that population, okay? That must mean if we picked out y successes, then we're going to have to pick out n minus y failures, okay? Because we're going to pick out a sample of size n. If y of them are successes, that must mean n minus y of them are failures. And how many total failures are there in the population? Capital N minus r. So from those capital N minus r failures in the population, how many ways are there for us to pick out n minus y of them in our sample n? Capital N minus r, choose little n minus y. Okay? So that's the number of ways that we can pick out y successes and n minus y failures in our sample of n. Now, this is a classical probability. So that's the numerator. That's the number of ways to see the event of interest, y successes. In the denominator, we want the total number of ways that we can pick that sample, regardless of how many successes or failures are in it. That's capital N, choose little n. How many ways are there for us to pick a sample of size little n from this population of big N, okay? And this is the hypergeometric probability distribution. It's a discrete distribution. These are discrete counts, okay? This is a number of successes. We can't have 2.3 successes. This has to be an integer. And this is the way we calculate the probability of that particular realization y.